stacks data structure. Okay, so assume you are attending a conference or a meeting at NIT Trichy. Okay, we do conduct so many events. Maybe we are conducting one event and we invite you to participate in this event, technical or some any lot of festivals happens here. So you want to visit this campus for some event, right? So you want to pack your bag. Okay, you want to pack your bag. So we assume you are having a bag like this, which can again this is an assumption only. You assume this way. You are having a bag with you. You want to place some t-shirts. You want to, because it's a 3-day event. Okay, assume you are attending an event at NIT Trichy, a 3-day event. You will be here for 3 days participating in various activities. Okay, so when you have to wear 3 different t-shirts or shirts, maybe you assume. Okay, generally we again avoiding that biasing between the gender, but we wear t-shirts generally when we go out. So I have made 3 t-shirts, I will place them here. Okay, I will place this t-shirt one over the other. So I kept my first t-shirt, then the second t-shirt and the third t-shirt in my suitcase or some bag like this. Okay, so you are having 3 color these t-shirts. Okay, right. Okay, so what is this RGB? I think you are aware of this RGB, red, green and blue. Red, green and blue. I think you are aware of this RGB pattern. You can form any color with these 3 colors. You can generate any color with these 3 colors. Okay, so we said that since it's a technical event and it has lot of machine learning and all other stuff, so we want you to wear t-shirts of day 1 wear red t-shirt, day 2 wear this green and day 3 wear this blue t-shirt, RGB. Okay, red, green, blue t-shirt we want you to wear. But once you came here, then you realize that you have placed it like this. Okay, you have placed your 3 t-shirts in this order. Now day one, what is the color everybody should wear? They should wear red color. So when you see this your bag, red color, it is nicely pressed. Maybe it is a shirt, nicely pressed, okay, and arranged properly. Now in day 1, you have to wear red t-shirt. So where is your red t-shirt or shirt here? It is at the bottom of the bag. So you have to remove your green color t-shirt. You have to remove your blue color t-shirt, then take this red color t-shirt. Okay, so what you are doing here, you are doing so many things here. You are removing green slowly, then you are slowly handling carefully. You are removing the blue color shirt, then you are taking away the green color one, red color one, which is at the bottom. You are wearing it. Remaining 2 you are placing. Remaining 2 again you are placing back. So you kept green here and then you kept your blue here. Like this, while placing back you kept in this order. Now on day 2 again we say you have to wear green. Again you have to open your bag, take away this blue, then use this green, right? Unnecessarily you are doing the again it's a small task, but again just an example to understand. Okay, so I am unnecessarily touching those nicely pressed cloths always repeatedly. See this blue color shirt, it was removed 2 times from the bag. What if we would have arranged this in my bag? If I would have arranged the t-shirts, in which order should I arrange the t-shirts such that I can wear a red on day 1, green on day 2 and blue on day 3? In which order should I arrange? It means you could have kept your blue t-shirt at the bottom, then the green one and then the red color one. In this pattern, if you store those t-shirts in the bag, then it is very easy. Day 1 take the red one, use it and keep it in another bag. Day 2 you take green one, use it in another bag. Day 3 you take it the blue one and use it. So it is very easy to take the t-shirts or shirts from the bag without disturbing or spoiling their neatly pressed shirt or t-shirt. Okay, so this is just an example to make you understand that depending on the problem that you have to wear RGB. If something is that whatever you kept last, if you observe here, which order did I place the t-shirts? Which order did I place the t-shirts? I like this. I am putting blue color first, then the green color, then the red color. In what order are you placing it? You are placing in the order in, see, the whichever you have placed last, whichever shirt or t-shirt you have placed on top last, that you will be using first. That will be using first. So here the principle followed in this data structure stacks, okay, is called last in, first out. Last in, first out principle. Right? So in this example, you understand, if I could have arranged the t-shirts in such a way by following this principle, if I would have known this principle, that whatever I will put last, that will be used first. In that order, if I arrange, then that shirts will not be disturbed, or in the sense they will not be pressed or some twisting in that ironed, nicely pressed shirt. Okay. So stacks is one data structure which follows the principle last in, first out. For problems like this, where whichever element you are placing last, that you want to use it first, okay, that you want to use it first, then you have to use stack data structure. There are so many applications where we see these stack data structures. Okay, you see, maybe in hotel or some function, you see a pile of plates, plates on top, then again top, again top, again top, like this, right? They are placing plates one on each other. In some function, if you go, you see plates are arranged in order. The fellow who is washing, he is having a garbage basket, all the used plates are there here. He is washing plate 1 and placing it here, plate 1. Then he is taking another one and he is putting plate 2 on top of it. Then he is taking another plate and putting it here, that is plate 3. So on, he is placing all those plates. Now, when you go to the, when you stand in the line or the queue to take the food in a function or somewhere, or maybe in your mess, right, which plate you will be taking? Will you take the down one? No, you are taking the first one, which is placed recently, right. So these are all the common examples of stack data structures. It has lot of applications in in computer science, especially in compiler design. Okay, how your compiler works, how does it executes program, right? It has lot of applications. We will be seeing, we will be trying to solve such problems. We will explore those concepts of stacks in detail. Okay, so this is just an overview of what application of a stack. What kind of situations can you use stack data structure? The principle followed is last in, first out, okay, or first in, last out. Okay, LIFO, or this also you can say first in, whichever was placed first will come out last only. Both, anything is fine, but popularly we say LIFO principle, last in, first out. Let us try to understand about this stack data structure. Okay, so stack is a simple data structure used for storing data, similar to linked list. Like in linked list, I am storing the data. Why we have come to linked list? Because there are some problems in arrays. So this is also another kind of a data structure which is used to store the data, right. In a stack, the order in which the data arrives is important. The order in which the data arrives is very important. Okay, so that's what a pile of plates in a cafeteria is a good example of stack. So all the plates which are being placed, the last placed one will be removed first, used first. Okay, so the plates are added to the stack as they are cleaned and they are placed on the top. I said no, somebody is cleaning the basket full of plates, right. So first plate he will be placing it here, then on top second, then third, then fourth, and then fifth, and so on. The one which was placed recently will be taken first. Okay. When a plate is required, it is to taken from the top of the stack. It has to be taken from the first, right. So the first plate placed on the stack, the first one, this P1 is the last one to be used. The first plate which you are placing is the last one to be used. Okay, so this is about little about stack. See the actual definition. Okay, stack is an ordered list of elements in which insertion and deletion are done at one end only. Because why I am saying one end? In linked list, in double linked list we have seen you can insert at the end, beginning, middle, you can delete at the end, begin and middle. Whereas in stacks you can do insertion and deletion at only one end. Okay, why? If you have a stack like this, you can insert elements from this entrance and you can remove elements from only one end, right? You are able to insert elements from one location and you are removing elements only from one location. That's why we say that so stack is an ordered list in which insertion and deletion are done at only one end. That end is called top. Okay, so it's like a stack is something like this, a container like this. So this entrance is called as top here, from where you are inserting and from where you are removing the elements. Okay, so the last element inserted in the first one, the last element inserted is the first one to be deleted. Whatever you add, you are adding numbers like this 5, 3, 4, 2, 1. So which one did you add last? That is 1. So only we can remove 1 first. If you want to remove 3, you have to remove 1, 2, 4 and then only you can remove 3. That's why it is called last in first out. It is called last in first out or first in last out list. Okay, LIFO list, we say LIFO list, last in first out. Okay, so some special names are given to the two changes that can be made on a stack. What you can do in a stack, you can insert elements and you can delete elements. Those two operations you can do. So some special names are given to them. What is the name? When an element is inserted into the stack, this is called push operation. It is called push operation. It means you are inserting an element into the stack. And when an element is removed, when you are deleting an element from the stack, that particular concept or the operation is called as pop. Okay, push and pop. Push, what it will do? It will insert a number. So you have created a stack. For example, you created a stack. Let it be S. When you say S dot push of 10, so 10 comes here. If you say S dot push of 20, so 20 comes here. Same way if you do 30, 30 comes here. After that, when you say pop, S dot POP, if you say 30 gets deleted, because we can do insertion and deletion only from one end. See, I am inserting 10, then 20 and then 30. But when I am popping out, I am doing it from top only. So first 30 will come out, then again if I call pop, 20 will come out, then again if I call 10 will come out. That is the order. So this, wherever you have problems, where you are in whatever order you are inserting, it's reverse order if you are removing. If it's reverse order you are removing, then that kind of data structure is called as stacks. Right. So that is about this push and pop operation. Okay, push and pop. Push means inserting an element into the stack. Pop means deleting an element from the stack. Now, trying to pop out an empty stack. So if the stack is empty, if this container box is already empty, but on this you are applying pop operation. On this empty one, if you are applying pop operation, it is called underflow. It will you have to display a message underflow. Okay, right. If you are trying to insert an element where the stack is already full, when the stack is already full, if you are trying to push another element, some 50, it is called overflow. Underflow, overflow. These terms will be frequently using in due course you will understand them better. Okay, so this is about stacks. So this is the example you see. It is kind of an data structure where I am inserting A, B, C. What is top? Top is a pointer. Top is a pointer which will always point to the top element. That is the on the topmost element. Top will be pointing to the element which is inserted recently. So in this if I do, there exists a stack like this. I am doing push operation with a D. Push operation with a D. So D comes here. See, D is inserted into the stack. Now my top changes to D. See, my top has changed to D now. this has become my top. When I do pop, when I do the pop operation, what it will delete? It will delete the topmost element, that is D is removed, my again top came back to C. My top came back to C again. Okay. So, this is how the stack data structure works. You are inserting and deleting at one end only, and this top pointer keeps on changing. It keeps on changing. Okay. Sometimes it will go to, if I insert D, this becomes my top. If I insert E, this becomes my top. Okay. If I keep deleting, if I delete this and this everything, this becomes my top. If this is also gone, if A is also gone, top will become -1. Top will be -1. So, whenever top value is equal to -1, it means the list is empty. The stack is empty. Okay. And whenever the top value is equal to n -1, right? Generally indexing starts from 0 like this. So, if n value is 5, if top, where is the top here? If top is equal to n -1, we say the stack is full. Okay. We will see the other concepts in this stacks. How are these used? Again, this is just a simple scenario or an example to explain you what kind of scenarios stacks can be applied. See, consider a working day in the office. Let us assume a developer is working on a long term project. This is the first thing he is working on. Okay. Now, the manager then gives the developer a new task which is more important. Okay. So, developer has given, manager has given a new task. This is task 1, then a new task, already he was working on a long term project. Suddenly, manager gives a new task, that is T2, which is more important. So, what generally the developer will do? He will put aside this T1 and he will start doing T2. Okay, that is what developer puts the long term project aside and begins work on the new task T2. Then immediately the phone rings, okay, which is the highest priority as it must be answered. Some other superior boss is calling or some important call is coming, maybe from family, right? Then that is the most important task, that is T3. Okay, some phone call is coming, that is the most important priority, the T3. So, developer will push this T2 also aside and start answering T3. Once the call is over, that call is completed, then immediately he will start doing his work. What he was doing before talking to this phone, he was doing this new task. Okay, he was doing this new task, right? So, that particular task he will be completing. Then after this new task is completed, again he will go back to the long term project. So, you see, first T1 was there, then came T2, then T3. So, once T3 is over, only then he will go to T2, only then he will go to T1. So, the last task which came, that is being done first. Again, this is a simple example to understand stacks. Now, we have to, stack is a data structure. We also studied about abstract data types. Abstract data types. Right? What is this ADT? I'll again little briefly I will give you what all this ADT is all about. See, in a simple program of addition of two numbers, I can declare variables like this, int a equal to 10, b equal to 20, and I can declare a variable c. Then I am writing c equal to a plus b. I am writing this statement, small program. Do you need to tell what is the meaning of plus to the compiler? No, you need not tell. See, there are something called data types. Okay, there are something called data types like int, char, float, etc. So, this a and b are two integer data types. On those two integer data types, I am trying to do a operation, that is addition, plus symbol I am putting it there. Am I specifically telling these two, the compiler, that the meaning of plus is addition? Am I telling this in my program? No, we are simply writing like this. Compiler understands that meaning. Compiler already knows plus means addition, minus means subtraction. So, you are not specifically telling the compiler that plus means addition. Whenever you put like this, it is understanding, it already knows plus means it has to add. So, there is some logic already written in the compiler. It will add these two numbers. That is the significance of this data type. For data types, for data types, you need not specifically tell the definition of the operations which you are performing on the variables. Okay. So, my point here is you are declaring variables. This is a data type, this is a data type. You are saying int ABC. You are doing so many operations on A and B on this integer data type or any data type. On some variables, you are doing some operations. You are not telling the compiler what is the meaning of these operations. Only you are declaring the data types, only you are declaring the data types and you are trying to, it is giving you the answer. That is the, that happens with data types. Now, what is abstract data type? ADT. Abstract data type means when you define the variables, when you define the data types, okay, you have to specifically tell, what is the operation you are doing. You have to specifically tell what is the operation you are performing on this abstract data type. That is what it is called, abstract data type. For anything which you tell the data type, that is called abstract data type. So, we are discussing about abstract data type. Normal data types, you need not specifically tell what operations you are performing, or you need not define those operations. Whereas, on abstract data types, when you define the variables, you specifically have to tell what operations should be performed. Okay. Or if you tell the operations, how that operation has to be performed, that instructions you have to give in abstract data types. That is why in linked list, we are writing the code of insertion operation on linked list. Insert at the beginning, maybe insert at begin is the operation. See, in all the programs, we are specifically writing the logic. We are defining how to do that insertion at the beginning. We are writing some steps. That is why data structures are abstract data types. All the data structures are abstract data types, meaning along with the operations, you should write the code, you should tell the system how to perform that particular operation. Okay. So, same way in stacks, stack is also a abstract data type. In this, you have to, what all operations we have, let us see. So, the main operations are push and pop. Okay. So, this push operation takes a integer data. Again, it takes a data, assume integer only now, for now, it can take character, it can take anything, but I am giving example, or you can even delete this data type, you can simply say data. Like this, you have to write this push operation, and for pop, you need not do anything, just you write pop, simply like this. So, push is to insert element into the stack, pop is to delete an element from the stack. Other than this, we have some auxiliary stack operation, means some additional operations. Okay, that is int top. So, top is a function, it will tell you where is the current top pointer. In this stack, you have so many elements, here your top will be available. This is the top because there is element 5, 4, 2, 1, something like this. So, currently my top is at 5. What is the index of that? 0, 1, 2, 3. So, this top function will return the last inserted element without removing it. It will tell you where is the last element, that will be given to you. Okay. Next, size. Size means how many elements are stored till now. How many elements are stored till now in the stack. That we can come to know using this size function. Again, is empty, is full, just to check whether the stack is empty or full. Okay. Depends on the problem when you are solving, whether you want to use this or not, but if you can only implement these two, that is enough, push and pop. Okay. If some problem expects you to find out this and this, you have to do those, you have to write those code also. You have to give the instructions of this. So, this is about the operations on stack, that is push and pop operations. Okay. What are the basic applications of stacks? Where do we use it? What are the general applications? The most important, it is used in compiler design. It is used in compiler design. So, whatever you are using C compiler, C++ compiler, that compiler internally uses stack data structure for so many things. Why? One is balancing of symbols. The first application is balancing of symbols. What is the meaning of balancing of symbol? Means, see, I will just give one simple example of printf in C programming. You are writing printf, you are opening a bracket, you are opening a double quote, you are writing here some string, hello, again you are closing a bracket, double quote, again you are closing a bracket, and this. How does the compiler checks that this syntax is true? How does it verifies? So what it will do, it will take this close bracket, it will put that in a stack, close. Then again it encounters double quote, it will put it here, double quotes. Again, this is not 11, it is just kind of double quotes. I will write like this, double quote. Then some strings are there, it will put that into buffer, some buffer it will store that hello, it will store, then encounters open. So if this is matching with this, if this double quote is matching with this double quote, then it will delete this. Okay, fine. Then again it encounters a close, it encounters a close, right. So if when I am encountering a close, it will compare whether in the top of the stack there exists an open or not, whether there exists an open or not. That way your compiler verifies every program, every statement of your program. This is just a simple example to demonstrate that, but it is widely used for so many tasks in compiler. Okay. So balancing of symbols, maybe if you give something like this, round, round, again open, like this. See, one round bracket, it has one closing. Then another round open, this is there. A square open, there is a square, like this. So compiler will verify whether there is the brackets are properly balanced or not. For those verification, we use stacks. But by default, the most important application is in compiler. Next, infix to postfix conversion. We will study these notations in this course. Infix and postfix, there are some kind of representations. So if a plus b is a infix statement, then the postfix will be a b plus. We will be writing it like this. Prefix will be plus ab. Okay, we will study these things. So to evaluate those kind of expressions, we use stacks. See, this I think you are aware of it. Implementing function call, that is recursion. When you write something, when you write a recursion function, void fun of int n. Okay, if n is equal to 1, return 1. Else you will write some n plus fun of n minus 1, something like this, return, right. So what it will do here, see, it is calling in recursion. Again, this is just an example. We are yet to study recursion in this course. So calling the same function itself is called recursion. Recursion uses stack. Recursion uses stack data structure. Okay. So next, finding spans, page visited history. See, when you are opening in Chrome browser, when you open multiple, you opened your university page. From there you clicked on department. From there you clicked on faculty. From there you clicked on his profile. When you click the back button, where does it goes? It goes back here. It goes back here. It comes to the landing page. So it uses stack data structure. It is keeping track of the links. First, which link is used, that is kept in the stack. Then second link which is used, that is kept in the second row. Then the next page in third row. So when you click the back button, it is going back. How it is going back to the same page? Because it is storing those web pages addresses in a stack. Those web addresses are being stored in a stack. That's why when you click back operation, it goes back to the old page where you clicked it. Okay. Same thing, undo sequence in text editor. You write something and you do undo. Control Z you do sometimes, right? Undo operation. So that is being filled on the stack. Again, matching tags. This is just an explanation. When you study web technologies, you can explore this, how stacks are used in matching the tags. So these are the basic applications of stack data structures. Okay. If you summarize what we have seen, so stack is an ordered list in which insertion and deletion are done at only one end. Okay, that's why it is called last in, first out. There are two popular operations. First one is push and other one is pop. Push operation inserts an element into the stack. Pop deletes an element from the stack. Okay, so this is just an example of doing that. So these are two most important operations of the stack data type, data structure. and these are few applications of stack data structure. Okay. So, in the next session we will be studying about the implementation of stacks.